All right, and welcome back to our chemistry flipped classroom. And we are beginning our stoichiometry unit. And so we're going to talk about this unit called the mole. And we briefly touched on the mole in class, but we're going to kind of delve into what it really is. And so you might remember from class that we said that the mole is just a counting unit, just like a dozen. And we know that no matter what we're measuring, if we have a dozen of it, we have 12. So whether we're talking about donuts or muffins or pieces of paper or eggs, a dozen is always going to be 12. And we have a few other counting units. We don't use them terribly often. There's this unit called a gross, which is actually a dozen dozens. So it's 144. We used to use that one more often, not super common these days. We talked about a ream of paper is 500 sheets of paper. So a ream of anything would be 500. And then in chemistry, this is the one that's important to us moving forward. So in chemistry, 1 mole is 6.022 times 10 to the 23rd things. So it doesn't matter whether we have a mole of moles, okay, well, then we'd have 6.022 times 10 to the 23rd moles, or whether we have a mole of M&Ms, we'd have 6.022 times 10 to the 23rd M&Ms, or whether we have a mole of atoms or molecules, which is much more common, and that's still 6.022 times 10 to the 23rd atoms or molecules. And this seems like a really weird number. But there's a reason for this number, just like there's a reason for a dozen and a gross and a ream. And it's really that it is a convenient number. Now I know 6.022 times 10 to the 23rd doesn't feel like a convenient number, but the thing that's very special about that number is that it makes it so that if we have a mole of carbon-12, remember carbon-12 is that isotope of carbon that has an atomic mass of 12. And so that atomic mass is in atomic mass units, which are tiny. Our scale is not capable of measuring in atomic mass units. But a mole has the same mass in grams that an atom or a molecule has in atomic mass units. And so that's what makes that number convenient, because it makes atomic mass in atomic mass units equal to molar mass in grams per mole. So a mole of carbon-12 contains exactly 12 grams. And so that's the reason that this is a convenient number, because that's not just true for carbon, that's true for everything. So if I have a mole of oxygen, it's going to have a mass of 15.9994 grams. Because that's the atomic mass of oxygen. So it's to make these tiny, tiny things measurable with a scale that we can use on an everyday basis. It's hard to wrap our heads around how big a mole is. If we were to count out loud, starting with the number 1, and we were to count 1 every second, it would take us trillions, sesquicentillions of years to finish, okay? It would still take 2.25 million years to finish it using a computer. If we had a mole of M&Ms, we said this at the beginning, it would cover the earth and it would be 25 miles deep. So a mole is a huge, huge number because atoms and molecules are so, so tiny. So this number, the 6.022 times 10 to the 23rd, we call it Avogadro's number in honor of the Italian chemist Amedeo Avogadro. He didn't discover it. In fact, what he proposed was that equal volumes of all gases at the same temperature and pressure contain the same number of molecules. But one of his students, Schmidt, was the first to calculate the atoms per mole, and his work was based on Avogadro's work. We're not really sure where the word mole comes from, to be completely honest. It might come from the shortening of the word molecule. It also means heap or pile, so a lot in Latin. Doesn't really matter where it came from. We just need to recognize that we call it a mole. Okay, so we're going to have a bunch of different relationships that we're going to talk about with moles. If we have gases, moles of gases, then we can convert to volume from the mole. We can use Avogadro's number to convert from moles to either atoms or molecules or particles. And we can use the periodic table to convert between moles and grams. So when we think about molar mass is measured in grams per mole. So the molar mass is the mass of 1 mole of a pure substance. So as an example, the molar mass of nitrogen is going to be 14.007 grams per mole. That's just the number that we pulled directly off the periodic table, but instead of units of AMU or atomic mass units, we're not measuring one atom, we're measuring a mole of the atoms. And so it has a molar mass of 14.007 grams per mole. In the same way, the molar mass of lead would be 207.2 grams per mole. And if we want to determine the molar mass of a compound, we simply have to add up the molar masses of the components of that compound. So the mole is just a useful conversion factor for us effectively. We know that 6.022 times 10 to the 23rd atoms of carbon weigh 12 grams. 6.022 times 10 to the 23rd atoms of oxygen weigh 16 grams. So 1 mole of any element is equal to the atomic mass in grams, that weighted average of isotopes on the periodic table of any element. So the atomic mass of any element in grams is equal to 1 mole of atoms of that element, which is also equal to 6.022 times 10 to the 23rd atoms of that element. So no matter what the element is, 1 mole of it has the mass that's on the periodic table in grams per mole. And so we can use this to convert between mass and moles and mass. And eventually we're going to take that out to 2- and 3-step problems. So if we want to know how many moles are in 150 grams of copper, we would simply take that 150 grams of copper. We would multiply it by 1 mole of copper per 63.55 grams of copper, again, pulling that directly from the periodic table, and find that we have 2.4 moles of copper. Your teacher has the wrong number of significant figures there, so don't follow my lead. In the same way, we can calculate, well, we're going to skip over that one for now. If we want to know how many grams of lithium are in 3.5 moles of lithium, we're going to look at the periodic table. We're going to see that the molar mass of lithium is 6.941. We're going to say, well, 3.5 moles of lithium. We know that there's 1 mole of lithium is 6.941 grams of lithium. And we're going to cross out our moles of lithium. And we're left with 24.3 grams of lithium. So pretty simple and straightforward, just a new conversion factor. Recognizing that 1 mole of any element is equal to its mass in grams from the periodic table. And that's where we'll stop for today. As always, if you have any questions, let me know. Look forward to hearing from you, and I'll see you in class.